Can you hear us?
Sure. Yes. I'll start sharing my screen. Let me know when everyone's able to see it.
Yep, we can see it.
All right, great. So hello, everyone. I'm going to take this next session on accelerating data science and machine learning workflow using Azure machine learning. So as we saw even in the last session, in order to deploy a completely end-to-end data science or machine learning workflow, a lot of work is initially required on the software engineering part, on the data engineering part, then setting up all the resources. So it is quite time consuming. So how exactly can we accelerate this entire workflow, and whatever the specific elements of setting up an enterprise level data science and machine learning workflow, how do we exactly bring it under one umbrella? So that is where Azure machine learning kind of helps us a lot. So I'll start with the session, but before that, I'll give a quick introduction about myself. So I'm currently leading the data science and the AI team at West Pharmaceuticals. And previously, I did work in Microsoft, and I'm really kind of well seasoned in domains such as machine learning, deep learning, IoT, robotics, as well as cloud computing. Particularly in the data science domain, I do have good experience in computer vision, time series forecasting, natural language processing, and with speech analysis. But apart from my day job, I do work in research projects, particularly related to AI, data science, deep learning, and even cognitive computing. And I'm part of a NGO called MUGH Research, and I'm also one of the faculty members at MUGH Research Academy. So, in case if any one of you is interested to know what I'm doing or get connected to me, you can reach out to me through my website or even through LinkedIn, and I'll be very happy to get connected. Now, before we get started, I just wanted to mention the topics that we are going to discuss. So first of all, I'm going to give a quick overview of how a enterprise data science and machine learning workflow should be like, and then how Azure Machine Learning Studio can provide a 360-degree workspace for completing or connecting all the various discrete dots in this entire flow of a machine learning solution. And at the same time, Azure Machine Learning came up with Python SDKs so that we can build our own custom machine learning pipelines in order to accelerate the entire process. And like other Azure services, which I really like about, Azure Machine Learning also provides a good integration with the various other services provided under the Azure platform. So with this, we'll get started. Just to give a brief context, I'm quite sure that most of you have heard about the Industry 4.0 expectations. But just to bring these expectations and trying to map with the expectations over AI and machine learning. So basically, all the different segments would be kind of driven by data-driven approaches. So it can be your various workflows, various systems, and everything has to be made as a smarter version of what we see right now. But in order to do that, initially, again, like this is quite common, but initially a lot of advanced research has to be conducted so that we identify where exactly the state of the art solutions can be applied. But the main problem is, and in fact, I was it's quite common, and people really think about this, that the research that the advancement in research that happens and whatever we get or leverage at the current industry, there is a huge gap. So how do we exactly fill the gap between advanced research and leverage the benefits of these technologies in a sustainable and scalable manner? And the last one is the reason why artificial intelligence and machine learning is gaining popularity. One of the main reasons is to reduce human bias or human errors as much as possible, and to automate things that is difficult to do, or maybe that is quite cumbersome, or that requires a lot of human effort, and because of which human error can come into picture. So based on that, we are going to look at how a scalable and sustainable machine learning workflow should look like. So typically, this is how the enterprise ML workflow should be like. So everything has to be, again, pluggable, and there has to be like a good amount of modularity in the entire solution flow. So there has to be a data layer using which or from which the data would be flowing through. the main machine learning engines or the algorithms that would be running, it would be on the analytics layer. And even in the previous session that we saw, that the results of this of the machine learning models has to be consumed in an end application, so which we are calling it as the user interface layer. And the way it is usually consumed is through a middleware API layer. Now, if you guys are aware of, like, most of the machine learning models are built may not be that much accurate. Even we were having that discussion before. So in order to improve the machine learning models in a more incremental way, we need to have something like a monitoring and a feedback layer. So basically, the monitoring layer would be used to see whether, like, how well the models are performing. And if the models are not performing well, then what exactly do we do? Do we train it with more data? Do we try to capture maybe data from different sources, diversify the entire solution? So for that, we need to have that feedback layer. Now, before even moving on to how Azure machine learning can help, I just wanted to highlight some typical challenges that a data scientist might face in such a production level solution. So as I mentioned, that we need to, the machine learning layer needs to get the data continuously from the data layer. So there has to be certain data pipelines that would enable the continuous flow of data. And at the same time, there are like strong infrastructural needs. Like, it has to provide some computational infrastructure to process large volumes of flowing data. And typically, if we look from a data scientist point of view, data scientists are actually not that much equipped in setting up such infrastructural needs. And at the same time, since there is no perfect model, and the first model may not work at all, so that is why there has to be an approach of rapid prototyping, which means that we need to build multiple versions of the model. We need to experiment with a lot of algorithms. We need to maybe fine tune it with various kind of hyperparameter tuning, which is like often quite popular in the data science world, which means like tuning your models to fit that particular problem, so as to get accurate and good versions of the results. And at the same time, once we have a good baseline model and which is working properly, we need to version the model, so that later, if we want to improve the model, we need to have another version so that we can compare both the version and select which one is working best. And at the same time, as I was mentioning, whenever the model goes into production, it needs continuous monitoring and retraining so as to improve it in iteration. And finally, as I said, in order to consume the results from the model, there has to be some kind of an API layer that would be fetching the results from the machine learning engine, and using which the end software application can actually consume it. So if we see all these challenges from a data scientist point of view, a data scientist might not be well equipped with meeting all the the software engineering needs, or maybe the infrastructural needs. So that is why we need something which would accelerate the entire process, so that a typical machine learning workflow, which might take, let's say, 7 days, can be done as quickly as within few hours. So that is where Azure machine learning comes into picture. And after this, we are going to take a quick walkthrough from the portal, but just to list out some of the key benefits that I felt Azure machine learning provides is, as I was again mentioning, that initially we might need to research with a lot of models. So for that quick research, Azure machine learning provides a Jupyter notebook interface. And then next, we would be seeing about AutoML feature from Azure machine learning. And when I would be giving the walkthrough from the portal, I would be explaining what AutoML is and how it helps again. And at the same time, Azure machine learning provides a nice designer view. So if someone doesn't need to code their baseline model just to get a feel of how the data is, they can easily leverage the designer view from Azure machine learning, where they would just need to form the code blocks properly and just connect everything, and the entire solution can be run within few minutes. And at the same time, whenever we were mentioning about the model versioning or the model registration process, at the same time, we need a data registration process. Because let's say if we train a particular model with some version of the data, and if we again want to train another model with another version of the data, so if the data, let's say, if it is not consistent, and if the distribution of the data is not proper, then the model results won't also be same. So in that case, it won't be an apple to apple comparison. So for that use case, it is always better to have a versioning for the data that has been used as well. And that is where the data registry or the data catalog feature that Azure Machine Learning Studio provides is extremely essential. And at the same time, we were mentioning about the model deployment process. So let's say if I have trained my model and I have a trained model available, so what's next? How do I ensure, move the model into a production process? So that is where model deployment as a web service from Azure Machine Learning helps to accelerate. And at the same time, in order to meet the computational needs, the different computational infrastructures can directly be created through Azure Machine Learning, or even if someone has their own computational environment, that can also be linked very easily with Azure Machine Learning. So with that, we would take a quick walkthrough of Azure Machine Learning from the Azure portal. So in order to create a Azure Machine Learning workspace, we can directly create from the Azure portal. So we can just create that particular resource, and once it is done, we can actually launch the studio from here, from the Azure platform. So if I go over here, so this is how the initial starting of the Azure Machine Learning Studio looks like. And as we were mentioning about the various features from Azure Machine Learning, so these are the very top and very helpful and useful features which Azure Machine Learning Studio provides. Now, for building quick models or researching with any code, the features like notebooks, which essentially open a Jupyter notebook using which we can run our Python codes or maybe R codes. And at the same time, it provides a nice feature about automated ML, which is the auto ML feature that I was talking about. And at the same time, it is the designer view using which we can just connect the blocks and complete an end-to-end solution. So with this, maybe we would start with some of these features first, and then we will take a look at the other features that we mentioned about. Now, let me open the notebook from here. So if I go to the notebook section, typically, okay, let me maybe open from here directly so that I keep this tab open. So once, okay, I think it got signed off. Anyways, maybe let me try from here. All right. So here, if we see, once we open the notebook section, okay, I think I opened it for a long time and it got signed off. Let me get started once again. So yeah, so once we are here, we can go to the notebook sections. So if I have my own notebook, I can definitely open a file like this, or for this particular session, I'm going to show a quick demo from the sample notebooks that are provided. And again, this Azure ML Studio comes up with nice set of tutorials that can be easily followed to kind of replicate what I've been seeing right now. So let's say if we want to take a look at the some of the tutorials that is provided, let's say I want to see maybe something like a image classification notebook. So here, if I go here, so this tutorials would actually give a good detailed explanation of how to implement this. But in case if I want to run this one, I can clone this notebook to my environment. And once that is cloned, I just have to attach to a compute resources. So here, if we see, show you the compute resources, there are like 4 different kinds of compute resources. The one that would be using the notebooks or notebooks to run basically the Python code or the R scripts, it uses this compute instance resource. So here we need to just create a virtual machine, or in case if we have our own, we can also attach to this and run our Jupyter notebooks through here. And at the same time, another good feature of Azure Machine Learning is, let's say if I have multiple data scientists working under the same workspace, the process of sharing notebooks is also very easy. So we would be able to see like whoever has been working on the notebook or whatever progress that has been done, so that if someone wants to build upon or continue upon that work, that can be easily done. Now, having said that, I would move to the AutoML feature, the automated ML. Now, as a data scientist, I'm actually not a very good fan of the AutoML part. But the thing is, AutoML actually creates a very easy workspace using which we can kind of accelerate the process of building a baseline model. So whatever the AutoML version of the models that are provided, the results might not be exactly most accurate or very good, but at the same time it gives us a very good baseline to compete with. So here I have already trained AutoML Python running a small data set that I had, and using which I saw that it was able to experiment with different set of models, with different set of pre-processing techniques, as we see. And at the same time, it would list out the various, the accuracy of the particular model, or any sampling amount that it did, then the duration that it has done. And at the same time, these metrics can also be changed. So let's maybe take a look at how easily we can create an AutoML pipeline or the flow. Okay, so let's say if I have a data set which is already created. So this is one of the heart disease data set which I was able to get from UCI's open repositories. And once the data set is already created and registered, for creating an entire end-to-end AutoML run, I would just need to select this particular data set. And once I go next, it would ask me to either select an existing experiment. So let's say if I want to show this one. And at the same time, as we all might know that whenever I'm trying to run something like a supervised machine learning problem, I would need the true values against which I will be comparing with. So here we need to select the target variable, which would be our true values for the comparison. So let's say we included the target column. And at the same time, as I said, we can either create a new compute resource, but if we already have one, we can just attach this resource and then go next. And based on the type of problem that we need to solve, we can easily select the particular type of problem. And let's say if I want to see additional configuration, for example, if I want to change the base metric, which would be used for evaluating the model, I can change it from accuracy to any one of these, like AUC ROC score or any average precision score if we want. Or let's say since this Azure AutoML would try to run across or iterate across different versions of algorithms, right? So if I know that some of the algorithms might not work, then I can just select this, and this will be added as a blocked algorithm, which means that the AutoML flow would not include this particular algorithm and would try to include the other version, so that if we know that which will be working best for this particular data set, we can reduce the time for running a entire AutoML flow. Okay. At the same time, we can set certain exit criteria, which means that if we want our model to run for some limited time, so that if it doesn't exceed a particular, a score, or if it doesn't converges within a particular time, then we can fix the exit criteria over here. And at the same time, we can set the validation type or any kind of concurrency if we want. So creating a model is very easy. So I would just show you from the one that I have already created again. So let's say if we see this this set of scores from here, and out of which, let's say I might know that the first algorithm might overfit on the data. Basically, it might be overtuned on the training data. And so that for a new unknown set of data, that algorithm might not perform. So in that case, I don't necessarily have to select the best performing model, but I can just select the one after that, or any one of these algorithms typically, and I can simply deploy this. So when I said deploying a model, so basically it would first create the pipelines under it. So this pipeline is nothing but step-by-step process which is required to move this particular the AutoML flow to a production system. So once the pipelines are created, it usually registers the model. So now I have a model version for the AutoML model. And in case if I want to, let's say, maybe retrain the model, or add more data and then again fine tune the model, then it would create another version of it. And let's say if I know that which version is which would work well, or let's say if the first version worked better than the second one, then I can just select that one and deploy it basically. And finally, once it is registered and once it is deployed, it creates a REST API endpoint. And we can basically consume the REST API endpoint and integrate with any UI application. So basically, consumption is also very easy. It would give the exact URL that is required, and finally, it can be integrated with any user interface application, like it can be Power BI dashboards or anything else, basically. So typically, we can see that how easy the entire workflow becomes right now. Like otherwise, a data scientist would have to be worried about basically first of all monitoring whatever that is happening in the production, and at the same time, even before moving to production, to be honest, there has to be maybe some specialized group of people working to create the necessary set of endpoints that would help in consumption of this model. So typically, whatever workflow that we have seen so far, the entire thing can be done within few hours. Okay. Now let me talk about maybe the designer view. So another good feature of Azure Machine Learning, which I felt, is the designer view. So in order to maybe code a complete machine learning solution from scratch, it might take some time, right? So in order to prevent that, we can just select the required set of blocks, maybe drag and drop over here, and based on that, we can run the various steps that we usually do as these kind of coding blocks. So basically, if I want to select my data set, I can create the data set. If I want to select any specific columns related to it, or maybe do some pre-processing or feature engineering, even that can be done. And at the same time, if I have, let's say, any kind of custom function that I'm using in the process of feature engineering or pre-processing, I can include that in my Python script. And using that, it can be easily used to transform the model. And at the same time, as we see over here, once we apply the particular algorithm, we can basically divide the algorithm and then basically score it, and even the results that we see over here can be fetched as a web service output. So that this is the particular one that is creating those REST API endpoints. So this designer view is pretty good. We can add the data set, and we can do any kind of data transformation if required. And at the same time, let's say any particular algorithm, and even the advanced one, like I was quite amazed to see that Microsoft does include the SMART algorithm. So whenever, let's say, if the data set is not balanced, and for classification problem for unbalanced data set, the majority class might always have a natural bias. So the model would be always kind of prone to predicting the majority class. So in that case, algorithms like SMART, which is a synthetic minority upsampling technique, helps to balance the data set, and basically the model results will be much reliable and robust. So I'm quite amazed to see that these algorithms are also integrated and included as a part of the designer view features. And at the same time, like, it is not always restricted only to Python. Like I see like a lot of options from for executing R scripts as well. And even it is not restricted to only structural data set. If someone wants to run a text analytics, or maybe something like a computer vision or an image processing algorithm, so these features are also there as a part of the designer view. And even more complicated deep learning models like DenseNet, ResNet are also provided as a part of the designer view. Now, coming to the kind of the features that really impressed me was this data set, or the process of creating a data registry. As I said, that if I want to register different versions of the data, I can actually register the data sets like this. And later I can use this data set for building my pipelines, or even through the designer view, I can use it. In the experiment section, like as we saw, that one was using the AutoML flow and the other was using the designer flow. So it creates as a experiment, so that later if it needs to be monitored and see that whichever has been used the maximum number of times, so these things can be easily tracked. And finally, we did take a look at the model registration and the endpoint part. Let me maybe mention about the data labeling part as well, because I felt that this is quite interesting. So whenever we work for certain deep learning problems related to images, most of the time, if we are working for something like an instance segmentation problem, or maybe something like a supervised classification problem, it requires annotated data basically. So basically, the images that we would be using, it has to be labeled. Now it can be of two types. So when we are doing something like a object recognition, or a bounding box detection problem, so basically the object of interest has to be marked with a bounding box. Okay. So so these kind of processes are very expensive, and when we actually work in an end-to-end data science solution, there are times when the data scientists would have to initially spend a lot of time in manually labeling the data, or maybe just getting the bounding box coordinates from the data, and then which would be used for finally the model training part. So those I would say difficult or manual effort can be easily reduced using Azure machine learning. So I would still say that it is there are like few more features which are coming in, but it is quite powerful, and the stage what it is right now, it is quite helpful for the entire data science community to move any research problem or solution to a problem into production in a very short time. Okay. So that's mostly it. I would quickly go back to my slide deck to cover some remaining part. Yes. So the next one that I wanted to cover was building our own custom machine learning pipelines using Azure Machine Learning SDK. Now, whatever we have seen so far, the various options that are available in the Azure Machine Learning Studio, we can also build our own custom versions of it, and we can have our own set of platform that can perform the same set of work. Maybe with it might have integration with some other features if required, but the same can also be developed right from scratch using the Python SDKs. Now, before going into the specific details, I wanted to mention two main types of production data science workflows that can happen from a very high level. So one can be related to online model flow, which means that if I have a live flowing data and if I want to retrain my model online, basically on the fly, and then get the results immediately. In that case, an online model flow, which is very effective and useful. And the second one is an offline model flow. So which basically means I am doing the model training part offline. So I know that my data is static, it will never change. And using that, I would build a trained version of the model. And when I have the trained version of the model, I would just need to deploy that particular model so that I can do live or real-time inference. So that is the case in which we can leverage the use of a offline model flow. Now, in order to explain more, so in the offline model flow, as I said, it would be like offline training. Like we know that the data is static, but the deployment or the inference part that would happen, it would be in real time. And for that, we would see this kind of a flow in which the data preparation, the data training, the packaging of the model, and even validation of the model can happen completely offline. So basically, we are not using or leveraging Azure machine learning for the initial, data preparation, transformation, or feature engineering, or training the model part, basically. But once we have the trained model, we can just upload the model into Azure Machine Learning and deploy it and register the particular model. So once the model registering is done, it can be easily versioned as well through Azure Machine Learning. And finally, as we were seeing, once the model is there, we can just deploy the model. So it would build the entire deployment pipeline, and it would create the necessary set of REST API endpoints for the real-time inference part. So once we have the necessary REST API endpoint, we can just simply, integrate with any user application where we can leverage the benefits of the model. Now, the second one is about an online model flow. So in an online model flow, as I said, the training would also have to be online, on real time, basically. And even the deployment has to be on a real time basis. Now, why would we go for an online model flow? So the main reason why an online model flow might be required when the data that is used for training is quite dynamic, when the data is being captured on the real time, and the historical data for that particular use case might not be either reliable or may not have a similar set of distribution across. So that is why a dynamic training model is very much useful, so that basically once the trained model is available online, the inference can also be done easily, and at the same time the deployment and the real-time consumption and monitoring part can also be easily done. So basically in this workflow, what we see is that maybe the initial part where the data preparation happens can be done by the user application, but the other stages like training, packaging, validation, and deployment can happen completely leveraging Azure machine learning. And once that is done, and once the REST API endpoints are received, it can be integrated with again an end user application for maybe monitoring the model or monitoring the results of the model. So this is a very useful part in which if the particular use case doesn't require any specialized attention from the data science team, or I would say it doesn't require a continuous specialized attention from the data science team, this kind of an auto-tuned and an online model flow would be really helpful. So the same set of pipelines, the custom pipelines that I was talking about, can actually be implemented using Azure Machine Learning SDK. So the process of even creating the data set, training the data set, packaging the models, then even deploying the models, and even getting the model endpoints can be done using that SDK, and it can be a custom version of what we see in the Azure Machine Learning portal. So typically this would how it look like. The user application would have an interaction layer, which is mostly the REST API layer, and using so that basically the REST API layer would be calling those custom machine learning pipelines, which would be again going back to Azure Machine Learning to use as the platform in which these operations can be done. And finally, again, whatever the results that are required can be relayed back to the user application using the REST API endpoint. So that's about the custom SDK part, which is quite a very useful feature. But another good feature about all Azure services, in fact, is providing that smooth integration with other Azure services. So we see that Azure Machine Learning can be easily integrated with some of these popular services like MLflow, Azure Monitor, maybe getting the live data from something like an Event Grid or SendGrid, and at the same time getting data from a SQL server, and running instances on top of Kubernetes, or maybe doing experimentation using Databricks cluster or Databricks notebooks. So these things can be done. And finally, for maintaining the CI/CD part of it, it can be also easily integrated with Azure DevOps, so that even let's say the process of deploying a new version of the model, or integrating with some changes that has been done in the backend can be easily automated. So that's mostly it. In order to summarize the entire thing, we talked about the initial part where we talked about the enterprise data science and machine learning workflow, and how Azure Machine Learning Studio can come into the picture for building a 360-degree workspace, and whatever whatever effort that is required to build that production level workflow can be really minimized. Like if something that takes 7 days can be reduced in a very short time, maybe 2 hours or 3 hours. So it can be really accelerated to a great extent. And at the same time, we do not have to be dependent on whatever options that is provided only in the Azure Machine Learning Studio. We can build our own custom machine learning pipelines that can perform the same thing, keeping Azure Machine Learning platform as the backend. And at the same time, if we want to integrate with other services from Azure, that can also be done very easily. So a completely scalable and sustainable machine learning solution can be built. So that's mostly it from my side. And in case if whatever I have said was difficult for anyone to understand, no worries. I can take questions right now. Or in case if we don't have that much time, you can shoot me an email, or we can get connected over in LinkedIn, and maybe we can discuss more on this. So that's mostly it from my side. I can open the floor for questions. Thank you. Okay, I can see one question. Features that enables developers with limited machine learning expertise to train high quality models. How about the computational resources needed for this model than usual? And how AutoML models are powerful that can fit into edge devices, scalable to AI and edge? That's a really good question, Afrit. So for your first question about how about the computational resources that are needed, as I was mentioning that in through Azure Machine Learning Studio, directly either we can create computational resources, like we can create certain VMs, and even it can be like GPU virtual machines required for certain deep learning applications that can also be created from Azure Machine Learning Studio. And connecting those compute resources to a machine learning workflow is also very easy. It's just just need to select that, and based on that it connects those compute resources. So basically from the infrastructural part of point of view, data scientists would have to just click few buttons and get it created, or even the same can be created using the Python SDKs that are provided. Now, coming to your question about how about also AutoML models are powerful, that can be fit into edge devices. Okay, so for edge devices, if you are talking about only the live inference part, and if that particular edge device has the capability of connecting to maybe internet and maybe make REST API calls, then in that case definitely it can be done, because it just needs to make those REST API calls. But if you're talking about, let's say, just the model deployment part, then the edge device would have to be connected let's say can be easily connected to something, let's say maybe like Azure DevOps, using which we can push the latest version of the model into the device. And once the trained version of the model is available in the device, then the model inference part can be easily done. But that's a good question. Okay. I see another question. Can you let us know one use case where I use online model flow? Yes. So one good example in which online model flow can be useful, it will be actually, in edge devices. Let's say in certain IoT use cases where we want to do something like maybe a real-time forecasting based on the data. So in most IoT use cases, the IoT devices might not be able to capture a good amount of data because the storage or the memory the memory resources are quite constrained. So so for that reason, based on the continuous flowing data, or maybe keeping a small time window, if a new version of the model has to be trained online, and based on that we need to get the results, and based on the forecasted result, let's say we want to do or we want to take any kind of rule based action. So in such use cases, when the volume of the flowing data is quite dynamic, but at the same time is quite limited, an online model flow is very much useful and helpful. So it would help us to make that real-time prediction, especially when the data is quite dynamic, and the historical data is not that much reliable, and instantaneous action needs to be taken. Okay.
Okay, so is there any additional questions, guys? So if there are any, either post it in the chat or you can come out of the mute if you wanna directly ask Aditya. Okay, maybe just like for a couple of seconds, Aditya. So or we
Sure.
can move on to the next session.
Sure. You maybe stop sharing now.
Okay, we don't see any questions. So thanks, Aditya. That's a wonderful session.
Yep. Thank you so
So
much.
that gives us a lot of overview on how to use, how to do the ML with a complete, CI/CD workflow.
All right. Thank you so much.
Yeah.
Thank you.
All right. Thanks. So probably.